right, so this is the new Slido. You'll want to swap out classrooms. Because we got a new lecture. Okay. Don't forget to QR code in. So whenever we get a question up, it'll come up automatically. Won't be the same QR as the previous one. Okay? Okay, did you get that, Devin? You need to QR in. All right. So now we're going to start talking about some bonding and such. We're finally getting into the real meat of chemistry. So ionic and covalent bonds, so chemical bonds are going to be formed when atoms lose, gain, or share valence electrons. These are going to be to acquire. What your book refers to and many people refer to as an octet. An octet means 8 valence electrons, and this is referred to as the octet rule. Now, I personally hate that terminology. Absolutely hate the octet rule terminology. What I much prefer to say is that it will take on a valence-like configuration, or it will take on a noble-like configuration. Okay? So every atom wants to be like the noble gases. And it will move left or right on the periodic table, losing or gaining electrons, to be like the noble gases. Okay? To have the same octet, the same valence electrons as the noble gases. Okay? So ionic bonds is going to occur when the valence electrons of atoms of a metal are transferred to the atoms of a nonmetal. Covalent bonds are going to form when atoms of nonmetals typically are sharing valence electrons between each other. Think of it a bit like this. If you have a really solid hold on something and someone comes along, grabs it, and they get a solid hold on it, what ends up happening? Do they take it from you? No, you're sharing it, right? If you have a very weak hold on something and somebody comes along and they grab it and try to pull it, what happens? You're transferring. Yeah. That'd be ionic bonding, right? If you both have solid holds on it, so neither one loses it, that's going to be covalent. Okay? Okay. Now, this is the nice, pretty pictures of these. So right here we have a transfer of electrons over on this side with a metal and non-metal. This is going to be ionic bonding, where we actually lose an electron or more to the other, the non-metal. Okay? And again, this is because the metals are very loosely holding their electrons. They have very weak attractions to their electrons compared to the non-metals. Okay? Remember those periodic properties we finished the not previous chapter but the one before that? That's those. This right here is a non-metal versus a non-metal. Both of them are going to hold on to their electrons fairly well, and so they're not going to actually transfer. They're going to share those electrons. Okay? There are exceptions to these quick and easy rules, but we don't really need to concern ourselves with them. For you guys, just knowing metals typically make ionic bonds, non-metals typically make covalent bonds between the non-metals. Okay? So this right here is the metals losing their electrons. This is an example of that with sodium. Notice when you lose an electron, you're going to go down to the next valence shell. Do you remember your valence shells being the periods? Another way of thinking about this is when you lose electrons, you move left on the periodic table to get to the nearest noble. Okay? And this is why sodium loses 1 electron. The nearest noble gas to sodium is actually what? If we look up at the periodic table, it's not going right, is it? It's going left, losing electrons. And so it's actually the period 2 neon, isn't it? Yeah. And so that's actually what it would have an electron configuration the same as. When we lose 1 electron, sodium would gain an electron configuration that's the exact same as neon. Okay, so we go ahead and look at the another metal losing an electron. This one's magnesium. It's going to lose 2 electrons preferentially. Again, if you look up at magnesium on the periodic table, you'll see it's 2 spots away from being a noble, isn't it? Yeah. That meaning it wants to lose 2 electrons to be a noble-like configuration. Okay.
The noble gases have a shell of valence electron.
Yeah, they have a full valence electron shell. Okay, and that's what makes them so stable. That's why they don't react with things.
They don't bond well.
Yeah. So the nonmetals, again, these are groups 5, 6, and 7 typically that you're going to be looking at. These have higher ionization energies. They're going to readily gain 1 or more valence electrons. This is going to form ions with negative charges. They're going to gain electrons until they have the same number of valence electrons as your nearest noble gas. For most of the stuff you'll work with, it's on periods 2 and 3. Specifically, period 2 is the majority of it. And so the majority of it does have 8 electrons when it's full. Okay? Being an octet. And this is where that octet rule comes from. Okay. Though there's one very important exception right off the bat. How many electrons does hydrogen have when it's full? 2. How many electrons does helium have when it's full? 2. Yeah. So, this is a negative ion. This can be chlorine. It has gained 1 electron, and thus it has become larger, right? Yeah. And again, if we notice, we look up at chlorine, we notice it's 1 step away from being a noble, isn't it? Yeah, so if it gains 1 electron, it's going to end up with a noble-like configuration. Okay. All right, so this is actually the periodic table of your elements. This is what I was talking about before. How can I always figure out how many electrons something wants to gain or lose? Well, I just look at it and go ahead and try to make my way towards the nearest noble gas. Okay? So, for example, nitrogen wants to gain how many electrons?
1, 2, 3.
Yeah, we just count over. 1, 2, 3, right? And that's 3 electrons that would want to gain. Okay, how about boron, by the way?
5.
Is it shorter distance to go right or left?
Left, technically, actually. So
Left. Yeah. Boron typically loses 3 electrons. And that's how it achieves a noble-like configuration. Okay? Carbon, by the way, is kind of interesting. It's in the middle, so it typically wants to gain how many electrons? 4, but if we tried to go the other way, what would happen? It'd be a +4, wouldn't it? Yeah. And so carbon is kind of one of those unique things where it holds on to electrons well enough that makes bonds really nicely. But yeah, it actually does that all the time. It will donate 4 electrons to 4 oxygens. It'll just as happily take 4 electrons from 4 hydrogens. Okay? It does some really crazy stuff. And that's why carbon makes up all life on the planet. Okay? Okay. So these right here are some formulas and names for common different ions. We can see we have the group 1, 2, and 3A. Those are our metal ions that will have common charges. And over here we have our groups 5, 6, and 7A. And these are our anions. Can anybody see any pattern within this? So the metals, the cations, cats are positive, right? So positive ion is a cation. Okay? And if we look at the cations, the names for them is just the name of the metal, isn't it? Everybody see that okay? Yeah. Okay. What if we look at the names of the anions? Ants are negative, and so negative ions are anions, yeah. And we look at the anions, and we see that does nitrogen normally get named nitride? No, nitrogen's normally nitrogen, right? And so what we do here is we always take the ending of all our anions and we change it to "ide." Okay? Oxygen goes to oxide. Sulfur goes to sulfide. Phosphorus goes to phosphide. Okay. Okay. These are some different typical ionic charges for different group numbers. Notice that you could have very easily just predicted all of this from the periodic table. This is just in case you forget how to do that. You can compare it to this chart and regain your ability. Okay? Okay, so these are some of the ions that are important in regulating body function. For example, sodium is actually incredibly important in your body. For most Americans, it's taken in such quantities to start becoming on the edge of toxic. But for life in general, up to about 150 years ago, sodium was the leading cause of people not being able to expand or survive in regions. Okay? Specifically salt. And this is the reason why it regulates and controls the body fluids. Potassium, everybody's probably heard of potassium before, right? Bananas. You can also get it from potatoes, orange juice, and milk. Also decent sources of potassium. Okay. This regulates the body fluids. It also has important parts in the cell function. Calcium is going to be, you've heard strong bones, right? Yeah, also needed for muscle contractions though as well. This typically comes from things like milk, yogurt, cheese, but you can also get it from greens and spinach, though you do need to be careful of how you treat those. Like if you boil off the spinach, the liquid around it will end up with most of the calcium. Okay? And so you'd have to drink the liquid around it as well, which sounds so appetizing. That's why boiling spinach is actually a terrible way to prepare it. Anyways. So magnesium, this is essential for certain enzymes. Anybody ever heard of enzymes before? Okay. They're the workhorses, right? They do all the stuff in the cells. They are usually proteins, but yes, they can be involved also in making proteins. They're involved in basically making anything or doing anything. Yeah. So they're going to have chlorophyll, nuts, and whole grains is going to have this. They're also responsible for things like muscle and nerve control as well. So incredibly important. Looks like you got it. Okay. So let's write the formula and symbol of an ion with 16 protons and 18 electrons. Note, by the way, that I've started putting it where you have the QR and the Q&A right before this. If for whatever reason you don't want to interrupt my flow with a question, you can post it here if you'd like. Okay? And I'll stop before we go on to the question to answer that. You'll get in just a bit. I have the quiz behind this. So write the formula and symbol of an ion with 16 protons and 18 electrons. Please note if you've logged into this this PowerPoint Slido, you'll automatically get the quizzes up whenever they come up. Okay. So write the formula and symbol of an ion with 16 protons and 18 electrons. Okay. Everybody ready? Okay, so let's join our quiz. Fantastic. Okay, make sure you get on that quiz. Okay, I'm going to go ahead and go on. Okay. So if we write that formula, which one is it? You have just 15, 12, 11 seconds to go. Dun, 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 dun. Go ahead and answer quickly. Okay. Okay. So, which one is it? You got it. Yeah, most people got it. How do we go about doing that? Yeah, exactly. So the first thing we need to do is write the protons. Protons is the atomic number. So 16 is what on the periodic table? Sulfur. You got it. And so the next part is we need to figure out the charge, right? And I was hearing a lot of good answers. Take the difference. If you have 2 extra electrons, that means that's a negatively charged 2, exactly, or 2 minus. Okay? And so it's going to be sulfur 2 minus. Okay, so let's consider the elements calcium and chlorine. Let's identify each as a metal or non-metal. Which one's the metal? Calcium, you got. Which one's the non-metal? Yep, you got. And I heard some people already get into the chloride part, which is correct. We are going to end up doing that. So state the number of valence electrons for each of those.
So chlorine has 7.
You got it.
Calcium
Yep,
has 2.
you got it. And what's the easy way to do that?
No, when gas is full, 1 less.
Yeah, that's an easy way. There's actually a little bit quicker of a way, which is to just go 7A.
Yeah.
Yeah. 7A means that it has 7 valence electrons. Yeah. On that periodic table up there, it's 17. So the 17 is the 7A, which is 7 valence electrons. Or you can also count from the left. You'd count 7 spots over, meaning 7 valence electrons. Or you can go the other way, which is 8 for the next one over, right? Minus 1, because we're 1 short of it. Okay, how about calcium?
It's got 2 electrons.
Yeah, so we look up there, we look at calcium. Where's calcium located?
Second.
Yeah, it's the second one on the which period? Period 4. Yeah, you can't see it. Next person over, can they look up and see it? Okay, so we're on period 4. It's the second one over, right? And so it's 1, 2 into there, meaning it has 2 valence electrons. Okay. The other thing you can use is it's group 2A, and so that is 2 valence electrons. Okay, so the next thing we're going to do is we're going to write the symbol, including its ionic charge and name of each resulting ion. Okay. So what is the ionic charge and name of each resulting ion if these 2 things react? Okay. How many electrons should calcium lose? It should lose 2. You got it. And that would leave it with what sort of charge? It loses 2 electrons. Electrons are negative, so it is 2 positive. Got it. Okay, and so we got the calcium so far, right? Ca. And it has a what charge again? Positive. Okay, so what would chlorine look like?
In that situation,
Yeah, Cl. And how many electrons does chlorine want to lose? Trick question. It wants to gain 1, right? Yeah. So chlorine wants to gain 1 electron. If we gain 1 electron, what charge would that be?
would be a -1.
Yeah, we got a 1 minus, right? Or a -1. Okay. So all we're using is those group numbers of how many electrons does it want to gain or lose. How many valence electrons does it have? Does it want to gain 1? Go to the noble configuration. Or in this case, lose 2.
How many is on there, right?
Yeah, literally we went calcium's 1, 2 in.
Okay.
We went to the left to the nearest noble. And so we took away 2 electrons to get to the nearest noble. Yeah. And then this one, we gained 1 electron to get to the nearest noble. Because it's 1 to the right.
So it's on the first one.
The chlorine. The chlorine is on the 7th one.
Uh-huh.
Okay.
Why do you lose one? I don't know.
one more electron than protons.
Ooh, okay.
We gained a negative charge.
Okay.
Yeah. We gained one negative. Yeah. Okay. So these are again the symbols. All right, so these ionic compounds, the elements sodium and chlorine react. They are actually going to form an ionic compound. We call that table salt. Every time you've had salt on food or you've, grabbed the salt on your table, that was always that table salt, sodium chloride. Okay? And that was always an ionic compound. This is actually what that would look like if you zoomed into the atoms. This is actually what that would look like if you zoomed to the crystal level. Okay? Interestingly enough, table salt crystals are very, very nicely square cubic, very pretty looking. Pretty cool looking, right? Okay. And so ionic compounds, these are going to consist of a positive and negative ions. The positive and negative ions are attracted to each other, and so they group together in such a way that we call these ionic bonds, which is just the attraction between a positive and a negative, right? Like little magnets snapping together. Okay? All right. Now, these are going to have very high melting points. Has anybody ever actually seen molten salt? No? You may have seen it in the form of like molten lava, but it only happens at very, very high temperatures. It's not something that you could do in like your oven. Okay? And so there are going to be solids at room temperature. Has anybody smelled table salt? Walked into a room and been like, that smells like salt.
No, actually, now that I stop and think about it, I've never considered this before, but salt on its own, well, it has strong taste. I've never actually smelled salt.
Yeah, you can't smell it. And the reason for that is because it has such a high boiling point, you can't get that much energy at room temperature.
I guess when I think about smelling and salt, I don't actually think about salt, I think about soy sauce.
Yeah. Yeah, you can smell soy sauce because it has things that actually boil at reasonable temperatures. Yep. Which are ammonia. So this is sodium and chloride, by the way. This is the sodium metal right here. This is the chlorine gas right here. If you were to combine those, you can make sodium chloride. And that is an ionic compound, which is held together because you have positive and negatively charged ions that are grouping together. So in a chemical formula, the symbols and subscripts are going to be written in the lowest whole number ratio of the atoms or ions. Of ionic compounds, the sum of the ion charges is always going to end up equaling 0. Otherwise, the ions would actually be pushing each other away. And so if you had a bunch of cations next to each other, it would just go pop and fly everywhere every time. Okay? It doesn't do that, so you know it has to be neutral overall. Again, the total positive charge has to equal the total negative charge for any ionic compound that you write out. And so right here we see NaCl. The sodium is a positive 1 charge. The chloride is a negative 1 charge. And so we end up at 0 total charge, don't we? And that's why the formula for that is NaCl. By the way, is there actually just a single NaCl floating around in there? No. No, they're actually repeated units over and over and over. Okay? Have you ever seen a molecule with your eyes?
It's impossible.
You all have. Okay? I want you to look around you. You see those hairs on people's heads? Okay, they're called polymers. And each of those hair strands is actually a single molecule. Okay? Technically, salts could be considered molecules as well. When you look at like table salt crystals, you can consider them as molecules, but that would be technically. Okay? Okay, so this right here is going to be magnesium. Notice with the magnesium, we actually lose 2 electrons to get noble-like configuration, right? And so that gives us magnesium 2 plus. The chlorines, on the other hand, are Cl minuses. So to get neutral overall, we have to have 1 magnesium and 2 chlorines, don't we?
Yeah, because each chlorine only needs one valence electron.
Exactly. And so that right there is the balanced formula for a magnesium chloride. Okay, this one's sodium sulfide. And so each sodium wants to lose 1 electron, right? Each sulfur wants to gain 2 electrons. And so we look at this and we need 2 sodiums for each sulfur, don't we? So that's the formula for sodium sulfide. Okay. We're going to have a quiz very soon. So, okay. You'll get it again once we go to the actual quiz part. Okay, let's go ahead and work on the problem. So write the ionic formula for the compound formed when barium 2 plus and chloride ions come together. So what would be the formula for barium 2 plus and chloride coming together? Okay. So let me know when you're ready. Ba2 plus and Cl minus coming together. How do we get the formula for that? What would that formula be? Okay, go ahead and answer. You got 15 seconds. Yeah, only 15 seconds. Yeah. Okay, so that is correct. BaCl2. And why is that? Well, barium 2 plus has a positive 2 charge, doesn't it? Cl minus has a negative 1 charge. And so if we want to get a neutral compound overall, we need 2 of the chlorines, don't we? Okay. And so 2 of the negative 1 charges would balance out the positive 2 charge. And that would give us barium chloride, which is BaCl2. Okay. Okay. All right, let's try a few more of these real quick. I want to do the quiz. So select the correct formula for each of the following ionic compounds. We have here Na plus and O2 minus. How do you always do all of these? You get a neutral, right? Okay. So how many NAs do we need to balance out the 2 minus? 2. And so there'll be Na2 to represent that there's 2 of those, right? And then there's going to be O, and we don't need a number because it's just one of them, right? And so which one is it? Yeah. Okay. Now the next one, Al3 plus and Cl minus. Which one's that? Got it. You got it. Mg2 plus and N3 minus. Anybody ever heard of cross multiplication before? Yeah. That was that old thing you used to do for denominators back in elementary school to get them to the same denominator. Yeah. You can use the same principle here. So for example, we can just take this number and put it down on the bottom for the Mg, right? And then take for the N, the number for the Mg.
So just switch.
Yeah. It's effectively the same thing as cross multiplying, isn't it? Yeah. So there we go. Anybody have any questions? No? Okay. Okay, let's go ahead and talk about naming. Naming ionic compounds is probably the simplest and easiest of the namings. Notice, by the way, that when you buy salt at the grocery store, has anybody ever noticed that, yes, it's table salt, which is sodium chloride, but it specifically calls out that it has iodide in it? Yeah. That's actually for your health. You actually need iodide in your diet, and most people don't get it in their normal diet. And so they actually add potassium iodide to many salts. If you were to get natural sea salts and stuff, it usually has iodide in it naturally, just from the ocean. It also has some gold in it as well, which is funny. So when naming an ionic compound, the name of the metal is going to be written first, and it's going to be the same as the name of the element. You don't do anything to it, just write out the name of the metal. The name of the nonmetal is going to be the first syllable of the nonmetal name, and then you're going to end it with "ide" to denote the fact that it is a negatively charged anion. So the space that's placed between the names of the metal and the nonmetal, so that you can read them and they make sense. So right here we have some examples. We have potassium and then iodide. We have magnesium bromide. And we have aluminum oxide. Okay. Everybody good with that so far? Okay. Notice we don't even need to worry about like how many there are. Okay? Yeah, yeah.
Try potassium.
Yeah, we'll get into those in a bit, but yeah, not for ionic compounds. Yeah. Okay. Oh, 5 minutes, thank you. Name the ionic compound K2O. This one will have a quiz. Okay. Okay, I'm going to get on the registration page here. So it was K2O, that's the one we're naming. And we'll finish on this one. Okay, everybody ready? Because this is the next step, we'll have the timer. So you'll have to click it real fast. Okay? Everybody ready? Ready, set, go.
That's what I'm saying. Krypton oregano. Great.
A is potassium.
Yeah, yeah.
It's a terse.
You guys like that?
Yes.
A little stuff like that, like I get.
Oh, nobody answered it. Krypton oregano.
I like that.
You know, the funny thing is, Krypton actually is,
It's an actual element.
like, yeah, it's on the periodic table.
Yeah.
Yeah.